So let's take a look at a couple of examples where we would calculate the average mass of an isotope, or where we're given the average mass, but we calculate the abundance of the individual isotopes. So for example, let's take a look at this first example. There's 4 isotopes of lead, and they have a variety of masses each, and we can also see that they come in a variety of different abundances. So the first thing that we want to do is we want to just summarize our data so that we can see what's going on. So what I've done is I've just written in a table where here's the isotopes, here's the mass of each isotope, here's their abundance. Now, because we need our fractional abundance, or our abundance not in a percent but in a decimal, what I did was I divided each of these values by 100 to get to a decimal value. Okay. Now, the second thing that we will do is we will then write out our equation. So I wrote out my generic equation where my isotope mass times my isotope fractional abundance. And then I know that therefore my average mass of lead is going to be the mass of lead 204 times the abundance of lead 204 plus the mass of lead 206 times the abundance of lead 206 plus the mass of 207 times the abundance of 207 plus the mass of lead 208 times the abundance of lead 208. So now what I can do is I can substitute the values from the table in. So I take their masses and their numbers. I can then multiply and gather and add it all up. And then the last thing, what we have to do is we have to take into account our significant figures as we talked about in class. So therefore, I will put this into 3 sig figs. And it'll be, 4 sig figs. And it'll be 4 sig figs because we are using our rule with multiple calculations where we'll go to the lowest number of significant digits. So this is the simplest type of question in terms of abundance, where we give you the abundance of each type and the mass of each type, and we have to calculate the average. A little bit more challenging type of question is one where you're given the average mass and the mass of the isotopes and asked to calculate the abundance. But regardless of which way we do it, we still start off answering in the same way. So the first thing we're going to do is we write down what we know. And so we know the isotopes and we know their masses. I don't know their abundances. So what we're going to do is we're going to use something that we learned in math, where when we don't know the amount of something, we give it a variable. And so what we'll do is we'll write a let statement. And now I'll always be looking for this let statement, because this is a justification for any further calculations that I do. So I'm going to say I'm going to let X equal my abundance of thallium 203, and I'm going to let Y equal my abundance of thallium 205. Without this statement, none of the calculations that I do from this point on are valid because I have no justification for them. There is nothing wrong with identifying something as a variable, but you have to state what that variable is equal to. And so here we're stating what our variables are equal to. Now we can use X and Y in further calculations. Due to the definition of percents and fractional abundances, we know that they have to add up the whole sample. We know that X plus Y has to equal 1. And so as a result, this allows us to get one of our variables in terms of the other. So now I know if X plus Y equals 1, then Y is equal to 1 minus X. From this point on, I'm going to do the same as I did for the first question, where I first write out my equation, I'll write out my generic, and then I'll write out for the specific example. So my average mass is the mass of thallium 203 times the abundance of thallium 203, plus the mass of thallium 205 times the abundance of thallium 205. And then we're going to substitute in our values, where this is my average mass that I was given, then it's the mass of the first isotope times its abundance, which we said was X, and then my mass of my second abundance times Y, except its abundance, which we're now saying is 1 minus X. We cannot go straight here and state its abundance is equal to 1 minus X, because we have to state this relationship as well to be able to use the 1 minus X in our calculations. Now we'll just distribute the 1 minus X, gather like terms, and we can solve for our value of X. Once we know our value of X, we can substitute it back in to our relationship our equation telling us our relationship between our variables to solve for the unknown. And now that we know our x and y values, we can put them back into a percentage.